Hey everybody, I just wanted to go over some strategies on how to solve FRQs and how to get started on them and how to scrap for some points. So the first thing you want to do is read through the entire question and be looking for the key unknown. What is the question asking about? What are some flags for topics, big topics that it's going to be talking about? And then what are the connections in the problem to that topic? Is it an equation? Is it a concept? What's going on? So go ahead and read through the problem real quick and look for the key unknown. In the question at the bottom, it says, explain why the athlete's angular speed increases between figure 1 and figure 2. So when we're looking at that, and it decreases between figure, when angular speed is what we're looking for, right? So, and that variable is angular speed. So look at the changes. So when we're looking for flags on the topic, it's either keywords or what is changing in the problem. And notice we have the diver going and rotating in the air and then hitting the water. It's not asking about the time going down. It's not asking about anything besides the rotation, the angular speed. And so we know it's not a gravity problem. It's not free fall. Gravity is not applying torque that's spinning the diver. So really it's just a rotational problem. So what are the flags then? Well, if I look from figure 1 to figure 2, what's changing? It is the mass distribution of the diver. There it's straight. Here we have the diver tucked in, and then in this one, the mass is distributed out away from the axis of rotation. And so that's going to help guide us, right? We know at that point that we can start looking for some equations. So let's make the connection here. And I'm going to look at my equation sheet. On my equation sheet, I've highlighted everything with angular speed in there. And when I'm looking at it, I'm going to key in on angular momentum equals rotational inertia times the angular speed. And so when I go back here, this reminds me a lot of the figure skater problem, where when the figure skater's arms are wide out, they're rotating very, very slowly. When the figure skater pulls their arms in, they're rotating very quickly and then straightening back out here. So that's describing this angular speed. So what do we need to talk about? We need to talk about momentum, angular momentum. We need to talk about rotational inertia, and we need to cover the variable that they're asking about. And so when we're looking at how to score this thing, if I do that, so 1 point for a statement that angular momentum is conserved. If you're talking about momentum, it's worth mentioning in your answer that momentum is conserved. So mass distribution, that has to do with the rotational inertia. You're pointing it out from figure 1 to figure 2. Talking about an indication about rotational inertia or inversely related, we would show that with our equation. And then everything else is really just tying it all together. So have we found the key unknown? Yes. What are the flags for the topics? So we came up with the topic of rotational inertia and angular momentum, and then we tied it all together with an equation. So you can scrap for points, and it's a really good way to get these problems started and tying everything together.